Hello everyone. Today we are going to start lecture 03 of class 8 mathematics chapter number 1, which is rational numbers. In this lecture we are going to study subtraction of rational numbers and properties of subtraction of rational numbers along with some examples. So let us start the lecture by understanding subtraction of rational numbers. Let a upon b and c upon d be two rational numbers. Let a upon b and c upon d be two rational numbers. Then subtraction of c by d from a by b. Then subtraction of c by d from a by b is defined as addition of negative of c by d. Now what is the negative of c by d? Additive inverse, which is minus c by d. So subtraction of c by d from a by b is defined as addition of negative of c by d to a by b. So if you have to subtract two numbers, you don't have to do anything. You just have to add negative of the another number to the first number. Let us take an example to understand this method better. Let us subtract 3 by 4. Let us subtract 3 by 4 from 5 by 6. Okay. Now according to this method we have to add negative of 3 by 4, which is minus 3 by 4 to 5 by 6. Now it has become the problem of addition of two rational numbers, and we know it. The denominators are different, so we will take LCM. When we all know LCM of 6 and 4 is 12. 6 into 2 is equals to 12, so 5 into 2 is equals to 10 plus 4 into 3 equals to 12, so minus 3 into 3 equals to minus 9. So we will get 1 upon 12 as the final answer, which is again a rational number. Now you can see very easily we carried out the subtraction of rational numbers using addition of rational numbers. How? By adding the negative of 3 by 4 to 5 by 6. So this is how we define subtraction of two rational numbers. Now let us take this method forward with the help of an example. Let the question be: the sum of two rational numbers is minus 3 upon 5. If one of the rational number is minus 9 by 20, find the other. As the question discusses about two numbers, there must be some another number. Let the other number be x. Let the other number be x. Then according to the question, sum of this x and minus 9 by 20 is minus 3 upon 5. Then according to question, comma, x plus minus 9 upon 20 is equals to minus 3 upon 5. Okay, so this is the question. Now what we can do is we can subtract minus 9 by 20 from both the sides, or we can take this minus 9 by 20 to RHS. By taking it to RHS, we will get x equals to minus 3 upon 5 minus 9 by 20. Now how do we calculate it? To subtract any number from another number, we just have to add the additive inverse. So what we will do is we will add negative of minus 9 by 20 to minus 3 by 5. And what is the negative of minus 9 by 20? Plus 9 by 20. To find the negative, we just multiply with minus 1. Now you can clearly see this method is nothing. Minus 1 is getting multiplied with minus 1 and it is becoming plus. So this is the complete method. Now again it has become a problem of addition of two rational numbers with different denominators. So we can take the LCM of 5 and 20, which comes out to be 20. To make 5 into 20, we have to multiply 5 by 4. So 5 into 4 equals to 20. So minus 3 into 4 equals to minus 12. Since here it is already 20, so we have to write 9 directly. And we will get minus 12 plus 9, which is equals to minus 3 upon 20. So the other number x is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other number is minus 3 by 20. So the other minus 3 upon 20, right? So we have to add minus 3 by 20 to minus 9 by 20 to get minus 3 by 5. You can verify it also. Okay, you can also verify it. You can add minus 3 by 20 to minus 9 by 20. Since their denominators are same, minus 3 will get added to minus 9, which will become minus 12 by 20. Then you will cancel out the common factor 4. You will find it to be minus 3 by 5. So our answer is correct and you can verify it yourself. Let us take another question with some different language but similar kind of method. Now this question says, what should be subtracted from minus 3 by 4 so as to get 5 by 6? Now again, there must be something, so let that number be x. Let the number be x. Okay. Obviously, some rational number has to be subtracted from a rational number to get a rational number. This is the property of subtraction which we are going to discuss. Let the number be x. Then, according to the question, we have to subtract x from minus 3 by 4 to get 5 by 6. So, an equation becomes minus 3 by 4. We have to subtract x from it and we will get 5 by 6. Right. Now to find x, first of all we have to take it to the RHS so that it may become positive. So it would be 5 by 6 plus x. Negative of x when transposed from LHS to RHS becomes positive. You can also see it as we have added x to both the sides. So here x minus x gets cancelled and plus x becomes on the RHS. Again, keeping x on its own position, bringing 5 by 6 to the LHS, we will get minus 5 by 6. Okay, and you will get x. So now you can very easily calculate x is equals to minus 3 upon 4 minus 5 upon 6. Clearly you can add negative of minus 5 by 6 to this. Now taking LCM of 4 and 6, we will get 12. 4 into 3 is equals to 12. So 3 into 3 is equals to 9. So minus 9. Similarly, negative sign. 6 into 2 is equals to 12. So 5 into 2 equals to 10. So we have done nothing. We have not used the method of adding of additive inverse of 5 by 6 to 3 by 4. We have directly added it using simple algebra. Okay. What we have done, we have taken the LCM of denominators like we do in the addition and we have subtracted them directly. So it is a bit easier and you will get the answer as minus 19 by 12. So minus 19 by 12 should be subtracted from minus 3 by 4 so as to get 5 by 6. So the required number is minus 19 upon 12. Okay, so it was very easy and this was the whole concept of subtraction of two rational numbers. Now let us move to the properties of subtraction. That is the properties that govern these subtractions. So the first one is closure property. Now what this property says is that if A upon B and C upon D are two rational numbers, then A upon B minus C upon D, that is subtraction of these two numbers, will also be a rational number. So closure property simply states that if you subtract two rational numbers, you will always get a rational number, and it is evident also. Let us take an example. Let us subtract 1 by 7 from 1 by 2 and let us see if we get a rational number. First of all, you can see 1 upon 2 and 1 by 7 both are rational numbers. So you can verify it for any kind of pair of rational number, but we are using 1 by 2 and 1 by 7 just for an example that how to use this property. Now LCM of 2 and 7 is 14. 2 into 7 equals to 14, so 1 into 7 equals to 7 minus 7 into 2 equals to 14, so 1 into 2 is equals to 2. So we will get 5 upon 14 as the answer. We will get 5 upon 14. Okay, so this was 5 upon 14. Clearly 5 upon 14 is also a rational number because it is written in the form of p upon q, where q is not equal to 0 and both p and q are co-prime integers. That is, there is nothing to be cancelled from p and q. So this was the closure property. You can verify it for various examples also. Now let us talk about the second property, which is a bit important, which is commutativity. Now clearly addition of rational numbers are commutative, but is it true for subtraction of rational numbers? Let's find out. This property simply states that the subtraction of rational numbers is not always commutative. Okay, it simply states that if a upon b and c upon d are two rational numbers, then a upon b minus c upon d is not equals to c upon d minus a upon b. So commutativity in subtraction of rational numbers is not defined, unlike addition of rational numbers. You can also verify it numerically. Let us take an example. Let us calculate 2 upon 3 minus 1 upon 6. Okay. Taking the LCM as 6, we will get 3 into 2 equals to 6. So 2 into 2 equals to 4 minus 1, and we will get 3 upon 6, which is equals to 1 upon 2 by cancelling the common factor 3. Now let us calculate 1 upon 6 minus 2 upon 3. Okay, let us calculate 1 upon 6 minus 2 upon 3. So you will get 6. Now it will be 1 minus 3 into 2 equals to 6. So 2 into 2 equals to 4. And we will get minus 3 upon 6, which is equals to minus half. Clearly half is not equals to minus half. So you can see when we subtracted two rational numbers in different orders, we got different answers. That is why subtraction of rational numbers is not commutative. Now let us move to the next property, which is associativity. Now what associativity says is that the subtraction of three rational numbers, or you can write the subtraction of rational numbers. No need to write how many numbers because it is one and the same. The subtraction of rational numbers is not associative, unlike addition of rational numbers, which was associative. So it states that if a upon b, c upon d and e upon f are three rational numbers, then a upon b minus c upon d minus e upon f. So here what you are doing is you are subtracting C upon D from A upon B first, and then we are subtracting A upon A from the result. That will not be equals to A upon B minus C upon D minus A upon F. So this is the associative property. You can also verify this property by taking three rational numbers, and you can get the same result, that associativity is not defined. That is, if you subtract three rational numbers in different orders, you will not find them giving same results. Okay, so you can take any three rational numbers and you can verify it. Let us move to the last property, which is existence of right identity. As addition of rational numbers had existence of additive identity, which was 0, here also existence of right identity is defined. Here the rational number 0. So here also 0 is the right identity. Rational number 0 is the right identity. Why do we are calling it right identity? Because it can only be applied on the right hand side. Let me tell you how. That is, for any rational number, A upon B, comma, A upon B A upon B minus 0 is equals to A upon B. So that is why we are calling it right identity, because you cannot kept 0 on the LHS, because if you do so, then 0 minus A by B will change the number to minus A by B, which is not possible, or which should not happen. So right identity is called because you can subtract 0 from the number and it will not make any change in the number. That was also the case in addition of rational numbers. In that case, you added 0 to the number and it did not cause any kind of change. That is why it was called additive identity. So this is the existence of right identity. Now let me tell you, or let me give you some examples to make these methods clear, to tell you how to use properties of subtraction. Let the question be, what should be added to 1 by 2 plus 1 by 3 plus 1 by 5 to get 3? Let the number be x. Then we have said that what should be added to this to get 3. So x would be 1 by 2 plus 1 by 3 plus 1 by 5 plus x is equals to 3. So we have to find x, right? We have added x to these three numbers, sum of these three numbers, and we got 3. So let us calculate. Let us first calculate 1 by 2 plus 1 by 3. So taking the LCM 6, we will get 2 into 3 is equals to 6. So 1 into 3 equals to 3 plus 3 into 2 equals to 6. So 1 into 2 equals to 2 plus 1 upon 5 plus x equals to 3. So we will get 5 by 6. Now 5 by 6 plus 1 by 5 we have to add. So let us take the LCM of 6 and 15, which would be 30. So 6 into 5 equals to 30. 5 into 5 would be 25 plus 5 into 6 is equals to 30. So 1 into 6 equals to 6 plus x is equals to 3. So we get 31 by x. So sorry, 31 by 30 plus x is equals to 3. Now you can calculate x by taking 31 by 30 on the RHS, and you will get 3 minus 31 upon 30, right? So we can calculate x by taking the LCM. Since 3 has nothing in the denominator, so there is 1. So you can take the LCM to be 30. So 1 into 30 equals to 30. So 3 into 30 equals to 90 minus 30 into 1 equals to 30. So 31 into 1 equals to 31. Okay. Subtracting 31 from 90, we get 59. and denominator would be 30. So the required number is, so the required number is 59 upon 30. So this was the question, and this is how we solve it using subtraction of rational numbers. Let us take one more example on this method. What should be subtracted from 3 by 4 minus 2 by 3 to get minus 1 by 6? So let the number be x. Let the number that should be subtracted from this be x. Then according to question, 3 upon 4 minus 2 upon 3 minus x, because we have to subtract x from these two numbers, difference of these two numbers. So 3 by 4 minus 2 by 3 minus x will give us minus 1 upon 6. Now again you can solve them by taking the LCM, which would be 12. Now 4 into 3 equals to 12, so 3 into 3 equals to 9, minus 3 into 4 equals to 12, so 2 into 4 equals to 8, minus x equals to minus 1 by 6, right? So 1 upon 12, 9 minus 8 equals to 1, so 1 upon 12 minus x is equals to minus 1 upon 6, right? Let us take x to the right hand side, then we will get 1 upon 12 is equals to plus x minus 1 by 6, because x would become positive by going there. Then again bring 1 by 6 to the LHS, we will get 1 upon 12 plus 1 upon 6 is equals to x. As when we transpose anything from RHS to LHS or LHS to RHS, its sign changes, so minus 1 by 6 becomes plus 1 by 6. So we will find x equals to 1 upon 12 plus 1 upon 6. Taking the LCM of 12 and 6, which would be 12, we will get 1 plus 6 into 2 equals to 12, so 1 into 2 equals to 2, which is equals to 3 upon 12, and cancelling out the common factor 3, we will get 1 upon 4. So x equals to 1 by 4, so the required number, so the required number is 1 upon 4. So that is how we do a question based on subtraction of rational numbers. So this was all about subtraction of rational numbers and property of subtraction of rational numbers. I hope you got what I taught you. Thank you for watching this lecture till end. See you in the next lecture. Till then, goodbye.